Hello, welcome back to Math 7 with Mr. Passon. Today we are starting a new unit on volume. We're going to talk a little bit about three-dimensional shapes today, then we will move on to actually calculating volumes next time. So we know several three-dimensional shapes that we've already been working with, and today we're going to be learning about cross-section. And that is when we cut a three-dimensional shape and sort of see what that shape looks like. Alright, so if we look at this cylinder below and we sketch what the figure would look like if you viewed from the top and from the side. So if we look at the top of this, well, it should look just like a circle. So let's go ahead and insert a shape of a circle. But if we look at it from the side and like just right on where that top, you can't see whether it stops, and it's going to look like a rectangle from the side. Something that looks like that. Alright, so we've got the top view and the side view, and there can actually occasionally be more than one side view. Similar to viewing 3D objects from different perspectives, a cross-section is formed when a 3D object is cut in various directions. Alright, so we're going to actually cut the shape and then look at that, what it looks like along our cut. Alright, so each 3D figure can be cut perpendicular to base. What shape is the cross-section formed by this cut? So we want to cut perpendicular to the base. So our base is sort of this region down here, right? And if we cut perpendicular to, that means 90 degrees to, we would get this rectangle sort of here, or if we cut the other way, we would get this rectangle here. If we cut this one perpendicular to the base, well, our base is this square. If we cut perpendicular to that, right through the middle, we're going to get a triangle. If we cut this one perpendicular to the base, we're going to get a square. Now, and when we pay attention to how we cut through things kind of matter a bit, and we're going to see actually kind of a cool video about all the different ways we can cut things. So we're going to think of the three ways, different ways to cut that can be sliced. It can be parallel to the base, perpendicular to the base, and at an angle. Alright. Now, visualizing this can be quite difficult, because even seeing these as 3D figures is by itself a bit of a challenge. But we are going to hopefully have some animations to help us figure it out, and we'll cover more of the practice in class. Well, the 5 figures below have been sliced perpendicular to their base. Alright. Parallel to the base and at an angle. Complete the statements below to describe the figure and their corresponding cross-sections. Alright. So what would form a circle? So forms a circle when sliced perpendicular to the base, but something else when sliced at an angle. Well, turns out this one actually we can't answer, because the only thing that when we cut we get a circle is the sphere. But a sphere also forms a circle when sliced at any angle, because a sphere will show a circle at any angle. Alright, so this one is a little confusing, because I think the person who wrote this wrong, and we're actually just going to cross out the word but there, right? And we can think, and it forms a circle when sliced at an angle. In fact, there's no way to cut a sphere where the part that you cut off doesn't look sort of like a circle. Okay, so let's see what forms a triangle when sliced parallel to the base. Alright, but a rectangle when sliced perpendicular to the base. Well, here we've got our rectangular prism, and our base is our triangle. So if we cut parallel to the base, we're going to get another triangle. But if we cut perpendicular to the base, we're going to see, as if we trim off this edge here, we're going to see that rectangle. So the triangular prism forms a triangle when sliced parallel to the base, but a rectangle when sliced perpendicular to the base. Alright, a blank, and a blank all have the same shape cross-section when sliced parallel and perpendicular. Alright, so, well, we already talked about the sphere. No matter which way you cut it, it'll always look like a circle. The cube, well, if you cut it this way, you get squares. If you cut it this way, you get squares. If you cut it the other way, as long as you're parallel to a face, you're going to get a square. Now, the rectangular prism, you always get rectangles no matter which way you cut, though you won't have the same rectangle. It will be the same shape because it will always be a rectangle. So you might get different size rectangles as you cut this one across, but they'll all be rectangles. The rectangular pyramid forms a blank when sized at an angle. So if we think about this and we cut at an angle, we think about what we're going to shape, what we're going to get, we're actually going to get kind of a trapezoid. So if we cut sort of from this side down to the bottom, well, it should get wider, but this side and this side will be parallel, so we get a trapezoid. Alright. Now, both the blank and the rectangular prism form parallelograms when sliced at an angle. So what could form a parallelogram when sliced at an angle? Alright. So both the cube and the rectangular prism. Now we'll try to look at some of those, and we're actually going to see some other shapes that you can get out of the cube as well. Alright, and the rectangular pyramid is the only shape that forms triangles when sliced perpendicular to the base. Go ahead and try to make a statement that would also be true, and then summarize what you learned today. I am going to add an addendum here where we watch a couple of other cube slices and other sort of cross-sections. Okay, so rather than the animation video, I found this better one that you can actually see. So if you cut the corner off a cube, you can form a triangle. If you cut along this, well, look, you can go ahead and get a trapezoid in there. Okay, if you cut a little further in, then well, now we've got rectangular sides. If we cut this way, notice it's got 1, 2, 3, 4, 5, so that's a pentagon. And if you cut sort of across all the faces, you can form a hexagon. And there's this actual cool video, so I am going to show the video. Oh, that is too big. Let's go this size. So we've got our net that we fold up into our cube. Then I think they're going to make it solid. Oh, there we get squares. And we see a cross-section. That's what we think about when we're cutting it up. Here we get a rectangle by cutting it along the longer side. What else do we get? Oh, tilt it out and you get that trapezoid. Oh, tilt corner to corner, and that's where we get our parallelogram. That one's sneaky, and that one's hard to remember. Here we've got another triangle, and that one might be an equilateral triangle. But then I think they're going to go just a little bit further and cut across all 6 faces. We get our hexagon. Might even be a regular hexagon. Might be all the sides are the same size. And then tilt it a little bit and cut it, and then you get the pentagon. So I think those are all the different ways that you can imagine cutting a cube. Now we can do all those with all the shapes and get a variety of different cross sections for a variety of different shapes. I don't know that you would have thought of all the ones with the cube, but one of the cool things is now that you've seen it with a cube, imagine it with other shapes as well. Okay? So there's lots of cool ones there, and think about which shapes that works for and which shapes you don't get a wide variety for.